Welcome to another Air Code 429 towing video. Today we will be talking about DNS over HTTPS. We will be talking about what DNS over HTTPS is, what is DNS, how to implement DNS over HTTPS, how to test for it, and what are the impacts to standard internet users and corporations alike. So firstly, I'd like to talk about the current DNS technology and how we resolve host names to IP addresses. So the current technology and how we resolve URLs in the browser to get to our final destination looks like the scenario on the right. Imagine you're sitting at your laptop as the client and you want to go to Aircode 429 or Twitter or apple.com. The current implementation as a standard user would be to open up a browser, go to the URL, just type in where you want to go, and hit send. Now when you hit send, I'm just assuming that you're in your home network, so you're behind your router. So the request goes to the router. And once it's at the router will then determine how to resolve that request. And in routers, they have their own DNS server entries where they define what DNS server they are going to reach out to in order to process the request. So say you've got your router here and you just sent it the request that you want it to go to Aircode 429. Now, somewhere, there's another box up here that's just a DNS server. And its main function is just to resolve this host name into this final IP address. So somewhere on internet land, your router says, okay, I need to resolve this host name to get the final destination. So within the router, it has the DNS entry. It then sends that request all the way out to the DNS server. That DNS server will then respond back saying, okay, Aircode 429 is at this IP address. At which point your router says, all right, take me there. It reaches out to the ISP and goes through multiple hops in order to get to the EC429 router or switch. At which point the router or switch will send that request over to the actual server itself over port 443, at which point that request will be responded to, sending it all the way back through the route back to your client. So that is the standard implementation of DNS. And it looks a little bit more different and complicated when you get into corporate DNS servers, but the main point is that when you make a request, your traffic is going to a DNS server somewhere, at which point that DNS server takes the URL you've typed in and gives back an IP address, a final location. But every single one of those requests that you make, whether it be Twitter or Apple or Facebook or your internal email, your internal admin portal, anything that you type in is captured by that DNS server in plain text. So even though our web traffic is encrypted with HTTPS or TLS, all of the actual requests of where you're going are still logged in plain text. And not only does your company see this through their DNS caching, but anybody who runs an endpoint, a DNS server, has the ability to see this over plain text. So anywhere you visit, they know. So the implementation of DNS over HTTPS is to get rid of this DNS server here and have the request go over HTTPS to a final DNS endpoint, so that if there were to be a man in the middle in your network, they would not be able to see in plain text those requests being made over the wire. So what I want to talk about is just that, DNS over HTTPS. It is currently being implemented by Firefox. So a little bit more information about that, just going to the Firefox support page. They talk a little bit about DNS over HTTPS, the benefits, and just like we said, DOH or DNS over HTTPS improves privacy by hiding domain name lookups from someone lurking on the public Wi-Fi or ISP or anyone else on the local network. And then they give some more information on how to enable the actual service itself. So you would just go to Preferences, scroll all the way down to Network Settings, scroll down, and enable DNS over HTTPS, and the only service provider is Cloudflare at the moment. And that's how you implement it. So the next part, I'll be talking about how we test for if DOH is working and how it looks different from the standard DNS implementation. So what I've done is install Pihole, which is a DNS Sinkhole, which basically means that we are installing our own DNS server on our home network. So instead of going outside of our network to get, I had mentioned there was a DNS server out here somewhere on the internet, instead of reaching out to that DNS server, we have our own DNS server within our own network, and we are utilizing that instead of a DNS server owned by somebody else. And also the advantage to having our own DNS server is we have the ability to whitelist and blacklist certain domains. So we get to see all of the traffic going in and out. That means we get to block some of the traffic coming in and block some of the traffic going out, sort of like a firewall for DNS. And I think if I just go to the actual page, we'll be able to understand that a little bit more. So I have Pihole running on my home network, and you can see it logs the total DNS queries. It shows how many DNS queries have been blocked, the percentage block, the domains on the block list. It gives you some nice graphics of the traffic and clients on the network and what they are, how many times they're requesting, what their traffic look like, the types of requests they're getting back, the domains they're going to, the top block domains, the top clients. You can see a little bit more about our network. We have devices on our network that are reaching out. If we go to a device in particular, we can see what actual requests they're making. So like I was saying, anywhere that you visit can be logged. So my current Mac device is at 192.168.1.150. That is my device. So if I were to go to, let's say, baseball.com, okay, let's reload this. There we go, baseball.com. So for anyone who has a DNS server, they can log, like I was saying, all of your requests to the sites that you want to go to, because they have to resolve baseball.com into an IP address. So by using Pihole, we are able to see all the requests going out and all the requests that are being blocked. So Pihole is a very nice service that you can use to bring your own DNS server in-house and make your internet a bit quicker. As you can see, we're blocking 7% of traffic. Pihole comes with a pre-installed blacklist, which knows which sites are bad and should be blocked, and which sites are good and which should be allowed through. So it helps with taking out some of the bad traffic on your internet, making it quicker, and providing a bit more security. So let's test, since we can now track our DNS entries, the difference between making a DNS request over standard implementation and making a DNS request over HTTPS. So, as I mentioned, my IP address is 192.168.1.150, and I am currently SSH'd into the Raspberry Pi, which is hosting the DNS server, Pihole. And we can see that the local address is 192.168.1.116. So what I'm going to do is actually just tail the log of DNS entries, DNS requests that are being processed by the server from this IP address. So I have two web browsers open. I have Google, which is going over the standard DNS implementation, and I have Firefox, which is going over DNS-over-HTTPS. So the difference is that Google, since it's not going over HTTPS, has to make a DNS request to a DNS server. And currently it's pointed at my Pihole server. So if we were to go to tennis.com, we would see everything is getting logged. So as soon as I type that in and made a request, it's getting tracked. Tennis.com and all of the different sites, trackers, advertisers, analytics that come with that. So let's get out of that. So now it's done. There's no more sites that are being resolved. Let's do the same thing in Firefox. Let's go to tennis.com. As you can see, there are no DNS resolutions being made. Everything that we saw was from Chrome, and we never saw anything again from Firefox. Let's try pingpong.com. Nothing coming through. Pingpong.com. So you can see the side-by-side difference between DNS and DNS over HTTPS. But what if you would actually like to see what it looks like over the wire? So here we go again. We have Wireshark open, capturing traffic from our IP source, which is my Mac, to the IP destination, which is the Pihole DNS server. So if we type in pingpong.com, we don't get anything, probably because it's cached. So let's go to a site that we haven't been to.com, or haven't been to yet. Let's try hockey.com. There we go. So the old query did not come through because it was cached and it already knew where that was. But if we type in a name that it doesn't know, it has to make that DNS request, and we see it right here. We can perform the same thing in Firefox. So I don't believe it has been cached in Firefox. So let's try that. And we don't see anything coming through on this end for hockey.com from Firefox. So our last test is we want to see that DNS over HTTPS is working. So as we saw in our preferences, network settings, DNS is going over Cloudflare. And Cloudflare's DNS server is at 1.1.1.1. So we can put our destination address as 1.1.1.1. Actually, let's stop this, redo it, just so we get a clean slate. So now let's make sure that it's working. So let's pick another site we haven't been to, maybe Nike.com. Here we go. Data going to 1.1.1.1 from the Mac to Nike.com. And if we look, it's encrypted. The TCP connection is encrypted, and the TLS connection, which is HTTPS, is encrypted. So nowhere here, using Firefox, do we get any sort of communication over the wire that we can track. So what are some of the implementations or implications of doing this? Obviously, as a user, this is huge for anonymity and not letting big corporations or internet service providers or people hosting your DNS server to be able to see and track what websites you visited. And some of the main providers of DNS servers are those like Google, and they not only have all of your information online in terms of the accounts you have, but they also have all the information of all the websites that you visited. So if you've ever wondered how can Google know what sites you visited, well, you're making a request to their DNS server and it shows them all the data that you've ever visited. Just like here in Pihole, if I want to see all the websites I've ever visited, you have that information at your fingertips. So for the standard user, the anonymity aspect of DNS over HTTPS is huge. It's another step, just like HTTPS being able to encrypt your web traffic. It's another step towards user privacy. But I also want to talk about the trade-off between being able to hide that data and also the impact to network visibility. So one of the main benefits from being able to see this traffic as a corporation is having that situational awareness and visibility into what your users are doing, and not even from a we are just monitoring them sense. You can start to predict anomalies and you can see traffic outside of your organization that is bad or malicious or should be blacklisted. So if I'm a corporation and I want to see, let me see if I can show my blacklist here. Okay. So if I'm a corporation, I want to see what's been blocked, and I want to be able to control how to block outside organizations that I think are bad. If one of the users in my organization, if their client gets compromised, and when I say client, I mean their thin client, their computer basically. If one of my users gets compromised and they make in their they have malicious software on their computer, and that software or Trojan or rootkit or anything of that nature wants to call home to the command and control server, and I discover that command and control server, I want to be able to blacklist that server so that nobody else in my organization can make a request to get to that location. However, if everything is going from DNS over HTTPS, you lose all of that network visibility as a corporation. So you are no longer able to see the good and bad traffic within your company. So you can't see whether a user's been compromised and reaching out to a known command and control server. You can't see if an employee is watching pornography or visiting explicitly bad sites on your network, because all of that traffic is encrypted now. So as a corporation, one of the main tools where you can have a little bit of oversight over some security is through DNS. But by implementing DNS over HTTPS, you lose one of those main tools in your toolkit for security. So I wanted to bring up this thought of, when is DNS over HTTPS most useful? When should we use it? When should we not use it? When it provides us a tool for anonymity, when it provides us a useful tool that's for the better, and when it would be used that's not for better, that's actually hindering us. So I just wanted to bring that up. I thought this was a very cool implementation. Firefox is currently the only one who has implemented it with Cloudflare as their backend compatible DNS over HTTPS server. Google is currently working on it, but I have not found a way to implement it myself. I have tried many times, but it is currently something that they are not offering to the public. And this technology is not going away. It is definitely here to stay. And it is something where the board level, your security directors are going to have to talk about the implications of enabling this tool inside your organization. What happens if you do enable it? What happens if you don't enable it? So I thank everyone for watching. And if you like this video, leave a comment, give it a thumbs up, and let me know if you have any questions.